Hi there and welcome to another video from Hegarty Maths. It's Mr Hegarty here, and in this video we're expanding brackets using the technique of difference of two squares. Now, linking to what we already know how to expand a double bracket. Pause the video, expand this and simplify your answer. Well, hopefully I would have expected you to multiply everything by x, so you did x multiplied by x and x multiplied by -3, so you'd have got x squared subtract 3x, and then you would have multiplied everything by this positive 3 here, and you would have got yourself positive 3x, and positive 3 multiplied by -3 is -9. Now, collecting like terms, you would have noticed this -3 cancels out with that positive 3, and you simply get yourselves the answer x squared subtract 9. And I would have expected you to do that. Now, I've actually talked to you about something similar to this before. I've shown you something like this before, 10 add 3 multiplied by 10 subtract 3. And I said when you have a case of a bracket multiplied by what I called in the past its conjugate, so 10 add 3, its conjugate will be 10 subtract 3, you will always just get the first term squared, 10 squared, subtract the second term squared, 3 squared. And that's 10 squared is 100, take away 9, is going to be equal to 91. And do check it out on your calculator. If you did 13 multiplied by 7, you would get 91 as we've got. And this came out when we were multiplying surds inside brackets. So we were multiplying surds in brackets, video or skill 2 on that section. So go back to your number section to see that. And it was a very important rule. So a bracket multiplied by its conjugate always gave you the first term squared, subtract the second term squared. And I actually even gave this a name. I called it the difference of two squares, and I'll formalise that in a second. Here's where we saw these questions come up in surds. If you don't know that, go back to that skill and practice that before going forward in this video. Otherwise, I want to check that you can do this in these cases with brackets involving surds. Well, in each of these cases, I had a bracket multiplied by its conjugate, a bracket multiplied by its conjugate. The conjugate of root 3 take away 1 is root 3 add 1. And here, the same case. So in each case, you would have squared the first term and subtracted the answer for the second term squared and simplified to 1. Here you would have done root 3 all squared, take away 1 squared. You would have got 2. Here you would have done 2 squared, take away root 3 squared, and you would have got 1. So I want you to be really good at that for this video, and it's also a good link to your other areas of maths. Now, in future, when you see something like a bracket multiplied by its conjugate, so you have x add 3 multiplied by its conjugate x subtract 3, I don't want you to go through the long process of x times x and etc. I want to look at that and say, it's a difference of two squares, a bracket multiplied by its conjugate, so the answer is going to be the first term squared, x squared, subtract the answer to the second term squared, which would be 3 squared. And we can work out 3 squared, so we better had and say that's x squared subtract 9. And I want you to do it quickly like that. In general, if you have a bracket multiplied by its conjugate, x add y multiplied by x subtract y, you're always going to get yourself the answer, the first term, x squared, take away the second term, y squared. And there's a name for this which we're going to see over and over again in maths, so it's better to learn this rule now. It's called the difference of two squares. The reason is the answer you get is a square number, take away a square number, x squared, take away y squared, the answer. So I want you to be super good at this. It's going to come up loads and loads and loads in maths. So let's proceed using the difference of two squares and work out expansion of double brackets quicker. I'd expect you to try all the questions first and then check your answer against mine. Pause the video, try, and then check against me. A bracket multiplied by its conjugate, so the answer is going to be the first term, which is x squared, subtract the answer to 4 squared. I can work out 4 squared, so I better had, that's x squared subtract 16. Done. Same in the second one. I've just got the x subtract 6 first, it doesn't matter. X add 6 is the conjugate of x subtract 6. They are conjugates of each other. So I'm going to get x squared take away 6 squared. And we know 6 squared, so we better work it out. That's x squared subtract 36. The last one, just want to show you, it's not always x, it can be other letters. So I've got a bracket multiplied by its conjugate. It's going to be a squared subtract 1 squared. We know how to work out 1 squared. 1 times 1 is just 1. This would be a squared take away 1. And we're done. Next one, pause, have a go. Same old stuff here, a bracket multiplied by its conjugate. So this is going to be x squared subtract 9 squared, which is x squared take away 81. Now, the next one, I put that in, I just put the number first, before the algebra. It doesn't matter, it's still 9 add x multiplied by 9 take away x, its conjugate. The same thing applies, it's just the first term is 9 squared, and the second term, subtract, is going to be x squared. We can work out 9 squared is 81, so it's 81 subtract x squared. Same as before, it's just the first term and the second term were swapped around. Next one, pause the video, have a go at these three. A bracket multiplied by its conjugate, same old stuff, it's just we've got two pieces of algebra here. It's going to be x squared subtract b squared, done. Same old thing here, it's not x's, it's p's and q's, and we've got the takeaway first, it doesn't matter. P subtract q multiplied by p plus q, a bracket multiplied by its conjugate. The answer is p squared subtract q squared. What did you get for this one? Guys, I'm sneaky, I put a trick in there. This is not a bracket multiplied by its conjugate. P subtract q multiplied by p subtract q. Neither of these is the conjugate of its other. It would only be a conjugate if one of them was p add q. So when you see a case like this, there's no difference of two square shortcuts. You just have to go back and do it the long old way. P multiplied by p is p squared. P multiplied by negative q is negative pq. Negative q multiplied by p, again, is negative pq. And negative q multiplied by negative q is positive q squared. Collecting like terms up, here we've got negative pq and another negative pq, so that's negative 2pq. We would get p squared subtract 2pq, add q squared. Please don't fall for that. I was a bit tricky there, but make sure you're reading your questions super carefully. Next one's pause the video, have a go. Same old stuff here, but there's a few numbers involved as well. Bracket multiplied by its conjugate. So the answer is going to be 3x all squared take away 4 squared. Now 3x multiplied by 3x is 9x squared, take away 4 squared, which is 16. Here we're going to have 4 squared subtract 5q all squared. Now 4 squared is 16, 5q multiplied by 5q is 25q squared. Be careful not to just write 5q squared here. 5q all squared means 5q times 5q is 25q squared. Last one here, we're going to get 5p all squared, take away the answer to 2q all squared. 5p multiplied by 5p is 25p squared, take away 2q multiplied by 2q is 4q squared. And we're nearly there, one last one with fractions just to make you think. Bracket multiplied by its conjugate, so it's the same old stuff. We're going to have 2/3 x squared, take away the answer to 1/7 squared. Now I'm just going to write this one out for us so we don't make a mistake. 2/3 x times 2/3 x, take away 1/7 multiplied by 1/7. Now you need to know how to multiply fractions, top times top over bottom times bottom. I'm going to multiply the 2/3 by the 2/3 first, and then I'm going to afterwards multiply the x by the x, because I can multiply in any order. 2/3 multiplied by 2/3 is 4/9 x squared. Take away 1/7 multiplied by 1/7. 1 times 1 is 1. 7 times 7 is 49. And there you go, we are done. Thanks loads for watching.